Welcome to episode 71 of our Snowflake SnowPro Core Certification In-Depth Training Podcast. I'm your host, Yakub Abdul Hakim from Bright Flux, and as a certified Snowflake user, I'm here to guide you through the world of Snowflake, ensuring you have the knowledge and skills to pass your exam with flying colors. Today, we're diving deep into the topic of Introduction to Sampling Methods in Snowflake. This is a crucial area for anyone looking to excel in their understanding and utilization of Snowflake, and it is especially important for those preparing for the SnowPro Core Certification exam. Sampling methods in Snowflake are techniques that allow users to select a subset of data from a larger dataset for analysis. This can be incredibly useful for performing exploratory data analysis, estimating database statistics, or simply reducing the computational load on your Snowflake instance. To start, let's talk about the importance of sampling in data analysis. Sampling allows you to make inferences about a larger population based on the analysis of a smaller subset. This is essential in situations where it's impractical or impossible to analyze the entire dataset. In Snowflake, there are several methods for creating these samples, each with its own set of advantages and applications. 1. Random sampling. This is the simplest form of sampling. Snowflake provides the random function, which can be used to generate a random sample of rows from a table. This method is ideal for ensuring that every row in your dataset has an equal chance of being included in the sample. 2. Systematic sampling. Another approach is systematic sampling, which involves selecting data points at regular intervals through the dataset. While this method can introduce a risk of bias, if the dataset has an underlying pattern that matches the sampling interval, it can be a rapid and easy way to create a sample. 3. Stratified sampling. To deal with potential biases and ensure that specific subgroups of your dataset are represented, Snowflake supports stratified sampling. This involves dividing your dataset into distinct strata or groups based on certain characteristics and then sampling from each group. This method is excellent for achieving high representation accuracy. 4. Cluster sampling. Sometimes it's more efficient to sample clusters or grouped subsets of the dataset, especially when dealing with large volumes of data. Cluster sampling involves selecting groups or clusters of data points rather than individual ones, which can significantly reduce computational load. Implementing these sampling methods in Snowflake requires a solid understanding of SQL and possibly some additional setup depending on the complexity of your dataset and the sampling method chosen. It's important to remember that the choice of sampling method is crucial for the validity of your analysis. Each method has its pros and cons, and the best choice will depend on the specific requirements of your analysis. In preparation for the SnowPro Core Certification exam, ensure you're comfortable with the syntax and applications of these sampling methods. Understanding how to effectively implement them in Snowflake can make a significant difference in your data analysis tasks and overall exam performance. In closing, sampling methods are just one of the many tools in your Snowflake arsenal. They are indispensable for any data analyst or data scientist working within the Snowflake ecosystem. Mastering these methods will not only prepare you for your certification exam, but also enhance your data analysis skills in real-world scenarios. Thank you for tuning in to today's episode. Join us next time as we explore another essential topic to help you ace your SnowPro Core Certification exam. Until then, happy learning, and I wish you the best of luck on your certification journey.